So what are things to be kept in mind here? Okay, what are, in the previous session, what did we learn? We learned the time complexity of this, divide and conquer came up to around theta of n. That's what we learned, right? That's what we learned. So this is with regard to substitution method. Whatever you saw in this was all with regard to substitution method. Also known as, to be very precise, it's known as back substitution method. Okay. Here it's all about, there will be problems on this. Okay. You are going to get problems on this, and the problems will be again a very simplest of parts. Okay, only 2-3 steps. If you can know the substitution method, similar to the sorry, similar to that only it will be. Okay, and you can sort of get from it. Okay, so 1 second. Yeah, fine. So yeah, okay, we are back now. What are the things we learned? Okay, things is with regard to substitution method. This is the time complexity you got. This is very important when you have to study about divide and conquer technique. This is one part of it. What's the second part of it? Second part is based on this, the problems will come. Okay, similar to how you did with regard to substitution method, the problems will come and you should be able to solve it. Okay, that's second method. That's second thing to be kept in mind. Okay, that we are going to see at the last. Okay, we are going to see at the last before we complete this entire module. Divide and conquer technique. Two things. One is substitution method. Second one is with regard to the master theorem. Based on those two things, we get problems. We are going to solve that. Okay, very nice problems. Very simplest of problems. You must be knowing this. Then you will be able to solve that. Okay, that's a other thing that you have to be kept in mind. What's the other thing? Okay, what's the next thing to be kept in mind? The next thing to be kept in mind is the time complexity using your Master's theorem. Okay, time complexity using Master theorem becomes very important here. Okay, what is that? What is to be kept in mind here? There are two things where people just by looking at it, you have to sort of remember. There's no proving and all. Okay, there's no proving. You just have to remember things. Now, what are the things that you have? The first one is you can put this entire, divide and conquer technique in a general form like this. Okay, in a general form like this. Now, what is this general form? Okay, what is this general form? If there is a problem, okay, if there is a problem, you can sort of divide that problem, divide that problem of what size A. This is of nothing but size A. Okay, not size A, of instances A. Of instances, what is the meaning of instances? How many times you can divide? Divide of A instances. Okay, just have to know what is this. Okay, of A inside A instances A, and size n by b. You can put it like this. And what is Fn? Fn is nothing but the time that is needed for both dividing and for joining that entire thing. Okay, so these are the things, and of course b will be greater than 1 only, because if you want to divide of size more than 1 only, you need to divide, right? If there is only one element, then not a problem. Then otherwise you need to divide it for more than 1. B value will be more than 1 only. So this is the first thing you need to remember. See, there's no proof here. Okay, there's no proof here. There's no solving here. You need to remember few things here, and this is one of it. The Master Theorem, there in the substitution method, you followed steps like going one after other. Here it is more about remembrance. What is the first thing to be remembered? This one. Okay, more like your formulas. You need to remember this. Tn is equal to, this is nothing but a generalized form of whatever you said till now. Okay, this one where A and B are positive values, and B where n by b is nothing but size, and Fn is the time for both dividing and for joining the things. Now, based on this Master Theorem, okay, based on this Master Theorem, this entire divide and conquer technique can be written in form of an equation which you can see right here. Okay, can be written like this. This is again the second thing which you got to keep in mind. Okay. Second thing which you got to keep in mind, the Master's Theorem. This is nothing but the Master's Theorem. Do you have to know from where did you get this? No. Okay. You have to know from where you have to got this? No. Do you have to remember this? Yes. Very much yes. This is known as the Master's Theorem. Okay. When you have two values A and B. Okay. When you have two values A and B, and if you want to represent the time complexity, and you can see the entire thing that's been written, okay, in terms of theta, where A value if it is less than B, A value when it is equal to B, A value when it is greater than B. Okay, these are the things that you get. Theta of n to the power of D, theta of n to the power of D log n, theta of n to the power of log B to the power of A. Okay, do you have to remember this? Very much you need to remember. Very, very important. Okay, how do you write it? How do you name it? Okay, you have to sort of remember this a lot, because this one we are going to do it when it comes to find out the time complexity and also to remember do the problems. Both time complexity and problems you need to sort of remember. Think more of this more like a formula. What is this? It is called Master's Theorem. What is Master's Theorem? Do you have to know for it? No. What is the thing that you have to remember for with regard to Master's Theorem? It is the expression used to find the time complexity of algorithms. Do you want to reduce this or you want to find out from where it came from? No. Okay. Those things. Okay. You have to have a clarity of what you need to study, what you should not study. Of course, if you got interest, if you got time, you could always go to Google and you can sort of take it out. Okay. How it came, all those things, it involves lot of steps which is not there. Only you have to remember this. You have to remember this. That is, there is no denying that. You have to sort of remember this. So based on this, okay, based on this, we are going to find out the time complexity of divide and conquer technique. Okay, divide and conquer technique. How we are going to find out? That's what the most important part now is. Okay, so let's do that. Okay, I'm just going to put that a little bit here. Now, yeah, I get a little bit screen now. Now I'm going to find out the time complexity of divide and conquer technique. Okay, using what is known as our Master's Theorem. First and foremost, you know very clearly that the divide and conquer technique, which is nothing but T of n, basically works like this with regard to a very simple formula. What is a simple formula? It is 0 when n is equal to 1, and then you have T n by 2 dividing for the time required for left part plus T n by 2 the time required for right part plus 1 the time required for joining the two things. Okay, joining both the left part and the right part. Can I write this? Can I write this entire thing into things like this? 0, n is equal to 1, and then write this. The thing new I'm doing, okay, just writing like this. Plus 1. Is it correct? Yes. Okay, very much correct. I can clearly write like this. N by 2 is nothing but 2n by 2t n by 2. Okay, now based on this, okay, based on this, be careful here. I'm going to do only 2 steps here. Only 2 steps only you have to remember. But of course, remembering itself is a very big deal here. Okay, so can I write this entire thing? Okay, can I write this entire thing as like this? So I'm going to write that. So time complexity of divide and conquer, which is nothing but T of n, is given by 2 T n by 2. Okay, plus 1. N plus 1. You know very clearly we don't take this 0 because it is for this thing only we need to calculate our time complexity. Now you see this. I'm going to compare this with the Master's Theorem's general form. The general form of the Master's Theorem. Okay, general form of what? Master's Theorem. General form of your Master's Theorem. If I do that, this is very important step. Okay, please understand this. If you can understand this, next step is very easy. What is the general form of your Master's theorem? Just like just now I wrote, I'm going to write it again. What was this? It was T of n is equal to A T n by B plus f of n. I'm doing what? I'm doing what is known as comparison. Please keep that in mind. Okay. I'm doing what is known as comparison aspect of it. When I'm comparing this like this is what I'm sort of getting. Okay. This is what I'm getting, which is nothing but when I'm comparing this with the general form of your Master's theorem, this is what I'm getting through. Now my job. Okay. Now my job is to compare these two things. If I'm comparing these two things, now what is the things that I'm going to get? See, be careful here. I'm going to compare these two. So Tn ka Tn, 2 is compared with A. Check this. Then T is T, N is N, 2 is, now B is compared with 2 here. Is it correct? Yes. Then 1 is compared with F of N. Is it correct? Yes. Can I write this? Okay. Can I write this entire thing now? If I write that, what is going to happen? A is equal to 2, correct? Okay. Then B is equal to 2, correct? F of n is equal to 1, correct? Very much correct. Okay. Now, what's the next thing? Okay. What's the next thing to be kept? I hope you will be knowing what is the thing to be done based on this. Okay. What's the best, things based on this. Now, what's one more thing that I need to do here? Okay. What is that one more thing which I'm supposed to do here so that the whatever I'm going to do later will become easy for me. Now, I know very clearly f of n is equal to 1. Yeah, everyone knows that. Right now, what's the next thing? Can I write this entire 1? Be careful here. Can I write this entire 1 as n to the power of 0? What is n to anything to the power of 0 is 1. What is 2 to the power of 0? 1. 3 to the power of 0? 1. 10 to the power of 0? Again 1. 10 to the power of 1 will become 10. 10 to the power of 0 is 1 only. Like this, if you can put for n is n to the power of 0 is equal to 1. Very clear, very correct. Okay. It is very much correct that n to the power of 0 is nothing but equal to 1 only. Okay. Can I write this? N to the power of 0 is nothing but equal to, n to the power of 0 is nothing but equal to 1. Okay. Now, what is the most important part here? I need to put all these values. Okay. I need to put all these values in terms of my Master's theorem. Where is my Master's theorem? Here. The one which you see right here. Okay. I need to put all these values right here. So I'll write it once again so that it will not be a problem. So I'll just write it once again. I know the values of what is my, one second, I'll just clear this off so that it will all be easy. Okay, so I hope you know why I have taken n to the power of 0, which is equal to 1. Okay, so it's a general mathematics things you must be able to know now. Okay, now keeping these values, now see this, a is equal to 2, b is equal to 2, fn is equal to 1. How did we get this? By comparing it. Okay, now what I'm going to do is I'm going to write this entire theorem like this. Okay, the Master's theorem. I'm going to write the Master's theorem. Okay, Tn is equal to, what is it given? It's given like this. Theta of what? N to power of d. Be careful, you have to remember this. Okay, theta of, because there are two things which you need to remember. This is with regard to time complexity, and also you are going to do this with regard to problems. Okay, and of course theta you can take like this till here. Okay, so this is with regard to, okay, theta of n. See this, n to power of d, then n to power of d log b to power of n. Okay, then because it's little bit confusing. Okay, where you write what? Log b to a. Okay, and where do you think these values will come? These values will come when you have certain constraints happening. What are those constraints? The constraints basically happen like this. When if a value, right? A value is less than your b to the power of t. if A value is equal to your B to the power of D. If A value is greater than your B to the power of D, then you have all these three values coming. Okay. Now I know the values of A. Okay. I know the values of B. Very clear. Okay. I can very clearly say, can I say that very clearly that, okay. Now just look into this. A is equal to 2. B is equal to what? Again 2. Okay. Now you can see very clearly here, B value, see, just look here, B value is all represented in terms of D, correct? It is all represented to the power of D. This is very, very important. You have to understand this. It's all represented in terms of B to the power of D. Can I write like this? I know, please understand this. This is the next important steps to understand what I'm writing. Okay. B is equal to 2. You know very clearly. Okay. Now, if I sort of want to write something here, okay, if I have to write something in terms of the ones which I need to have it in terms of B to the power of D. Okay, B to the power of D only I need to know. So where I can represent that B to the power of D, or where I can get the value of, D value. Where I can get the D value, that becomes very important now. Okay, now compare the value right here. You see this? N to the power of 0. Okay, n to the power of 0. When you have n to the power of 0, check with regard to n to the power of 0, where you have all those things. You have something right here. Okay, n to the power of D. N to the power of D. Okay, n to the power of 0, I can even write this as n to the power of D right here. Okay, if I do that. Okay, if I do that, what am I supposed to going to get? I'm going to get D is equal to 0. N to the power of t, if d is equal to 0, n to the power of 0, n to the power of 0 is nothing but equal to 1. Okay, t value will be equal to 0. Now you know very clearly b is all in terms of b to the power of d, b to the power of d and all. Okay, so based on this, can I write this entire equation like this? B I know very clearly because b is equal to 2. Understand this, this is the most important part. Okay, b is equal to 2. Can I write this as what is the thing that needs to be run? B to power of D is equal to 2 to the power of 0, correct? B to the power of D is nothing but equal to 2 to the power of D only. 2 to the, or else one more step. 2 to the power of D. This is nothing but equal to 2 to the power of 0. Okay, 2 to the power of 0. That is nothing but equal to 1. Okay, very much equal to 1. So can I write like this now? That B is equal to 2. B to the power of D is equal to 1. Very clear. Okay, it is very clear. Now you check. Now I need to check whether what is the equation that is going to hold true for this. You know very clearly A is equal to 2. B to the power of D is equal to 1. So can I write this entire thing? Be careful here. Can I write this entire thing as A greater than B to the power of D? Say 2. What is the meaning of it? 2 is greater than your 1. Okay. 2 is greater than your 1. Now check where do you think I'm going to get that values from? 2. Where do you think I have this, A greater than B to the power of D? Right in the third aspect of it. Okay. Right at the third aspect only it will be very clearly that I get A greater than B to the power of D. Okay, A is greater than B to the power of D now. Very clear in this. Okay, very clear in this. Now you see for that what is the value you're supposed to get? You are supposed to get the value of theta. Okay, theta to the power of n to the power of log B at A. Okay, so based on this only we need to get the value. So can I write that now? I'm going to write that all those things right here. I'm not doing anything new. Please understand. Okay. This theorem is all about remembrance and little bit of common sense that are supposed to get right here. Okay. So let's go and sort of write that same thing right here. I'll be writing it down here. Can I write that now? Okay, the time complexity, that third one is getting satisfied. So the time complexity, which is nothing but t to tn, okay, will be given as what? Will be very much given as theta of n. I'm going to write this, nothing new. Okay, theta of n log b and a. This is what you're going to get. Okay. What's the next step? Next step is again theta. What's n? What's the value of n? I don't know what is n. I'll write the same thing right here. Then log. What's the value of b? B is 2. Log 2. Okay. Log 2. Then a. What's the value of a? Again 2. Now you must have to know what is this value. What do you think is log 2 to the value of 2? It is nothing but equal to 1. Okay. Log 2 to the base 2 is always equal to 1, or in very simple terms, whatever the general value, when you get log a to base a, it is always equal to 1 only. Okay. It's always equal to 1 only. This you have to know. When you have same this and here, I don't know, I don't remember what you call this is and what you call this. I think it's called to the base a, and what you call this, sum a. Okay. So that when you have same numbers right here and here, you get the value as equal to 1. You could check using your Google, it will work. Okay, it is equal to 1 only. Can I write this entire thing now? Now can I write this entire thing as like this, equal to theta of n. This entire thing is equal to 1 now, power of 1, which is nothing but theta of n. And what is this? The time complexity. Same thing only you got even in substitution method. Of course, you get the same value only. Whichever method you imply, you're going to get the same thing. This is what? It is nothing but the time complexity of what? Of your divide and conquer technique. Using your Master Theorem. That's very important. Using your Master Theorem, this is what you're going to get. Same thing only, theta of n. Even in substitution method, you got theta of n only. Of course, both the things will be same only. Okay, this is Master's Theorem. Using Master's Theorem, this is what the value you get. Okay, please understand what is the important step here. I'll just repeat again, once again, what is the important steps here? The first important step is the general time complexity of divide and conquer technique. When you write a general aspect of it, this is what you're going to get. Okay, what is that? Tn is equal to a t n by b plus f of n. Okay, this is the first thing that you need to remember, right? The first thing that you got to remember is this one. What's the second one? See, this is the first one which you should never forget. What's the second one? The second one you are going to do is with regard to whatever is the Master's Theorem. Okay. So this will be my second important thing to remember. Third one is all about comparing. Okay. It's all about comparing whatever which you already know. Where did you get this? You know very clearly where did you get this? From here and from here. See this? Okay, you know very clearly where you got that. You're going to compare whatever the value of A right here, whatever the value of B right here. Okay, then whatever the value of f of n right here. Okay, then based on that, you found out the values of A, B, f of n. Okay, A, B, f of n. You found out the values of it. A, B, f of n is equal to 1. Based on that, you figure out the entire values. Then when you put those values right together like this, okay, Other important steps where you need to remember is right here. B is equal to 2. So I can write that as B to the power of D, which will become equal to 2 to the power of D. Okay, D value is already 0, which is equal to 1. So which is nothing but B to the power of D is equal to 1. Then based on that, A value is equal to 2. Okay, B to the power of D value is equal to 1. Okay, 2, and you can see very clearly A value is very much greater than your B to the power of D, which in very simple terms you mean 2 is greater than your 1. Okay, 2 is greater than your 1 only. Then, so based on that, you can see where is that A to power of A greater than your B to power of D is satisfying this one. Okay, this third constraint or the third condition. So I put that right here. Tn is equal to theta of n log B to power of A. That only I put those values right here. Okay, see this. Okay, Tn log B to power of A only I'll check. Okay, and log B 10 to power of A. Log, theta. Okay, n log 2 to power of 2. Log t to power of 2. Then you have theta of n to power of 1. Okay, you have your n to power of 1. So what is the meaning of that? You get that time complexity as time complexity as what? DAC, which is nothing but equal to your Master's theorem. Okay, this is a thing that you got to keep in mind. Now, one second. One second, just be back. Yeah, sorry. Okay, now see, this is what it's been done. Okay, the entire thing is all about this. Now, what are the things you learned? Okay, what are the things you learned before we move to the next aspect of it? You started to know what is divide and conquer technique. Then you studied what is known as the pictorial representation of it. Okay, very clearly that there was a pictorial representation of it. Then see, divide and conquer, pictorial representation. Then you studied about the algorithm, the general algorithm of your divide and conquer technique. Okay, you know about the general algorithm. Is that correct? Yes, very much correct. Then you took one example. You took about the sum of n numbers and all. Then you found out the recurrence relation of it. Okay, what was the recurrence relation? The recurrence relation here. Okay, the recurrence relation here was with equal to t power of t to n is equal to, you saw this one, right? 0. You got your t n by 2. Sorry, n by 2 plus t n by 2 again plus 1. That was your recurrence relation. Very correct. Then based on this recurrence relation, you found out the time complexities. Okay, you found out what is known as the time complexities of it. In the time complexities, what are the two things that you have? You had what is known as, first one is substitution method. Okay, the second one is with regard to Master's theorem. This is huge, this is huge. You study so many things right here, right? So many things you learn. Fine, that's all fine. But is that the end of it? Is that the end of it? Now, after this, it's all about applications. Okay. What is mean by applications here? You're going to learn about the specific applications where you talk about what is known as, what is merge sort, time complexity of it. Okay. Binary search, time complexity of it. Quick sort, time complexity of it. Okay. And then one more thing called maximum minimum, again time complexity of it. 4 applications. Then you move into decrease and conquer. At the last part of this module, you move into decrease and conquer. But before doing that, okay, before doing that, probably, or probably in the next class, you're going to sort of look into this. There are some more things which is remaining. What is that? Problems. I like problems a lot. Okay, there is problems based on what? Based on these two: substitution method, Master's theorem. Okay, there are problems based on this. Any one problem you may get, so you basically have to be ready for it. And how do you do it? Very simple. Okay, probably in tomorrow's class, okay, we are going to sort of look into that. Okay, again we are going to go more like, you know, step by step procedure for it, for each and every aspect of it. So what we'll do is we'll take a strategy very simple. We'll take a problem. We are going to solve both with substitution method and also with regard to Master's theorem. Okay, so that whatever they give, you should be able to do it. Okay, there's a lot of, you know, step-by-step procedures which you're going to get, and you should be able to sort of solve that without any problem. Then we move into what is known as the application part of it, where you're going to learn about what is merge sort, the same old flow. Okay, what is an algorithm, and then to find out the time complexity of it. Then binary search, algorithm, time complexity. Then quick sort, algorithm, time complexity. Maximum, minimum, algorithm, time complexity. See, just by looking at it, probably you must be able to understand by now that all these are standard questions. There is no interior questions that are going to come here. Standard 8 to 10 marks questions. You know, it will come 8 to 10 marks. Very clear. Okay. Very less chances that you get a smaller question, which is nothing but a question which may come for 5 marks, 6 marks, and very less chances. It's more like your mathematics. You go start and you end it like. Okay. In tomorrow's class, very important class. I think tomorrow's second hour class, if I'm not wrong. Okay, tomorrow's class will become very important because we are going to solve problems. Okay, we are going to solve problems, and then we move into what is known as the merge sort of it. Okay, I like merge sort because merge sort is a classic example for your divide and conquer, right? It's a classic example. You divide that entire thing, then you conquer it, which basically means you're going to merge it. Then you get what is known as the sorted array, right? You would have seen it even in your third sum also. Same thing only, you're going to look into it. So first we are going to take merge sort as an example to figure out how to, you know, sort of move forward in terms of divide and conquer.